Hello everyone, welcome back to our channel, Chamber of Embed AI Secrets. Today I'm thrilled to take you on a magical journey through my project, Secure My Car. Just like Harry Potter's adventure at Hogwarts, our project involved a mix of spells, technologies that brought everything to life. So let's dive into the magic behind it. Speaking of socket programming, socket programming enables server-client communication using sockets, which are endpoints identified by an IP address and a port number. The steps involved in this communication are create, bind, listen, accept, data exchange, and close. Data is exchanged between the sockets using connection-oriented TCP and connectionless UDP. Imagine socket programming as the Harry's owl Hedwig from Hogwarts delivering messages for him. Owls carry messages between Harry and his friends. Socket programming allows different systems to communicate over a network. In our project, it enabled real-time server-client communication. Moving on to the next objective of our project, BuildRoot Linux distribution. BuildRoot is an open source build system that simplifies the process of creating custom Linux-based systems for embedded devices. It automates the compilation and integration of the Linux kernel, bootloader, and the root file system, making it easier to develop lightweight and optimized embedded Linux distributions. Think of it as a sorting hat of our embedded system. It helps you choose the right components and create a custom environment. Just as the sorting hat selects the best house for each student, BuildRoot lets us build a minimal Linux-based system tailored to a car's needs. We used BuildRoot for running our BeagleBone-based server and client logging system. I2C is like Platform 90 quarters at King's Cross Station. The platform with its clock SCL pin manages multiple trains, that's devices, arriving and departing. The clock ensures that all trains communicate on the same platform without any chaos. Just as I2C uses a shared bus and clock signal to coordinate between multiple devices. In our project, we use these communication protocols, UART and I2C, to interface our sensors, which you will later see in our project. Up next is FreeRTOS. FreeRTOS offers lightweight, real-time performance with efficient task management and inter-task communication, with robust signaling mechanisms like semaphores and queues for synchronized access to the resources. This is crucial for maintaining stability in embedded systems. Think of FreeRTOS as Hermione Granger, efficient, organized, and capable of juggling multiple tasks at once. Just like Hermione manages her studies, the time turner, and helping her friends out. Moving on to the final element before the demo, inter-process communication. We all enjoyed the scene in Harry Potter and the Sorcerer's Stone where the Dursleys were overwhelmed with letters from Hogwarts. Each letter represented a piece of information that was delivered efficiently and in the right order. Inter-process communication, IPC, works similarly. In our project, IPC, like the flood of letters, ensures that different parts of the system, which are the processes, can exchange messages smoothly. Just as the letters are managed and sorted to avoid chaos, IPC mechanisms like message queues synchronize the sensor data flow, keeping everything organized and deploying with any packet loss. Now let's move on to the demo.
Hello. So this is our project, Secure My Car, and this is the what you are seeing on the screen is the block diagram of the project. This is the overall project overview. So here it's like this is one multi-threaded BeagleBone server, and it is interfaced with 3 clients. one TIVA client. It is interfaced with fingerprint sensor and temperature sensor. Other TIVA client is interfaced with ultrasonic distance sensor, and both the sensors are sending those data to the BeagleBone server, and this BeagleBone multi-thread server will log that data on BeagleBone client. And this communication is established through socket communication, and these clients are interfaced through UART communication. So this is the basic project overview. So as you can see, so what you are seeing is the hardware setup. So this is the BeagleBone server, and this is the BeagleBone client, as you can see there on the screen. And these are the TIVA clients. This one TIVA client is interfaced with fingerprint sensor, and the other TIVA and the temperature sensor, as you can see. And the other TIVA client is interfaced with the ultrasonic sensor. So the basic working principle will be like when I give my fingerprint, then at that time if the fingerprint matches, then the 10 sensor readings and of the temperature and the 10 ultrasonic readings from the other TIVA client, they both will be given to the BeagleBone server here, and from the BeagleBone server through Ethernet communication, the data will be logged into the BeagleBone client. Smart dashboard of a smart sister car. And so now I'll show you the working. So as soon as I press the fingerprint, yeah, so here the fingerprint is matched, and so it will send the temperature readings as well. Okay, and as now what you are seeing on the screen is the server. So here on the server, multi-threaded server, here the 10 temperature readings are being sent, as well as this server is also telling the other client to send ultrasonic readings. The ultrasonic 10 data readings are being received.
So once the flag is set, it will send the temperature values as well as the ultrasonic readings to the client. So this is the server screen, and here is the client screen, where you can see the ultrasonic and the temperature values are getting logged.
So you can see here the like when the sensor is when there is an obstacle detected, it will log the data on the and send it to the multi-threaded server, and the multi-threaded server will then send it to the client.
Yeah. So explain the client. So
once the data has been received through the UART on the server sends it to the client, and the client logs the data in different files. So can you show the output here?
Yeah. So this BeagleBone client will keep on logging the data, like the temperature readings along with the timestamps.
Along with the timestamps, all the temperature readings are seen on the screen.
Yeah, and
the other file contains the ultrasonic readings.
So here the ultrasonic readings are being given.
Yeah.
So this is the overall project overview. This is the whole Secure My Car system.